Yes, I think everything is fine. So now I'm going to teach you some today class which is related to your differential equation type. Okay. So today my aim is to discuss some basic idea about and then we study some other topic. Okay. So I am starting with a definition about differential equation. So what is differential equation? Let me check on the YouTube it is perfect clearly or not. So today my aim is to discuss. Okay, everything is fine. So a student, myself, Mr. Divyansu Ranjan Srivastava, and today my aim is to discuss about some basic topic which is related to ordinary differential equation or differential equation. So this is the introductory class for us. Okay. Uh, You have some idea about some integral type problem. Because it is already given in your book. So, and then you have some idea about the integration about differential. Okay. And many formula which is related to like Bernoulli or okay. So today I'm going to start a called name as differential equation and their formula and formation and solution. So what is definition about differential equation? So students, definition says that you have some derivative or a differential of one or a dependent variables and more independent variable. These two key points which is comes from this definition, which is an independent variable and dependent variable. So we can say that it is the differential equation. So it is the combination of a differential equation which have some derivative and they have independent variable or dependent variable. So here is some list of the differential equation as a example purpose we add in this slide. Okay, this is not a slide, this is one note class. So basically you have not more difficult to see my class. Okay, it is a clear visible. So here some definition about differential equation. What is differential equation? So you may say that some dependent variable or one or more independent variable which is basically used in differential equation. So here is some equation written here which is dy is equal to x plus sin x dx. Okay, you may be write like this: dy upon dx is equal to x plus sin x, and write it, make it as a equation first, and then here is some equation, make it at, wait a minute, let me erase it. Okay, so here is the second equation for it, and there is a third equation. Okay, so these are the example of basic differential equation and their type. So these are the basic type for you, and we may be denoted as when dy upon dx, it is denoted as y dash like this, and d2y upon my dx square, which is denoted as y double dash, and then dq upon dx cube may be denoted as y triple dash, and so on. You may be when the power increases, your dash will be also increases. So these are the otherwise stated as y dash and y1, y double dash or y2, yn or yn will be denoted as something like this. So these are the basic fundamental denoted of differential, which is basically the rate of change of any which is used in it. So basically the differential equation used yes, and this differs in some mathematical problem or many way area where we use this differential equation type equations or anything. So basically, the differential equation is just used for rate anything. Why use differential equation? So wait a minute. Which is because real world processing changes continuously. So we use in many areas. First one is the to model real world phenomena, and which is used for the explanation or example as like population growth, temperature changes, motion of objective velocity and acceleration. You see in class 12 the basic formula about the velocity, which is also used in a mechanic portion also. So motion of object, velocity, acceleration, and spread of disease, current and voltage in electrical circuits, chemical reaction, fluid flow, heat flow, where we use the portion of these differential like equations or many things. Okay, so we make a use for the prediction of solved for the some equation like population grows today. You can predict its size after 10 years, and by using a numerical analysis data, we use the and implement in equation. So rate of understanding the rate of thing like this. So derivative respectively used for the rate of change. It means ki how much time we gain to the changing or anything else. So these are the basic definition about differential equation. So ki you may be understand about something real lifetime problem or any curious and something control system in engineering, curious control in car, flight control in aircraft, robotics, and electrical circuits and signal processing and FPGA, embedded system simulation relevant to the your work. FPGA is basically this is also my part for by using differential equation we use for the as a video coding simulation like use for uh, implement some coding. Okay, it is the basic coding for STM, which is a high definition resolution. So basically used in a video coding. Okay, scientific problem mathematically which can solve Newton's law, which is basically motion type. So motion, uh, motion in Newton of motion, Newton's second law, first law. These are the used in class 2 already. We study about it. So equation Maxwell equation is regarding something like electromagnetism and which is the use in a quantum mechanics, continuity equation in fluid mechanics, the symphonics. So these are equations helps to understand how things change and predict what will happen next. Okay, so these are the basic use of differential equation. So you maybe understand it. So come to the next point, which is ordinary differential equation. So ordinary differential equation, and then we study about partial differential equation. So ordinary differential equation, what it means? It means wait for a second. Just I am small the size of a derivative with respect to single independent variables, which is called as ordinary differential equation. So ordinary differential equation, what it means? It means you have some equation involved with respect to single independent variable. So single independent like equation first, two, three, and four, which are the example of ordinary differential equation, which have include a single independent variable. Because here we see that how you can identify these independent or independent variables. So you may be first of all you may be right at like this. So you say that here is the dependent variable and these are independent variable. Here is the something a dependent or independent variable. So ordinary differential equation are the basic example for you may be written as here equation first, two, three, and four all are ordinary differential equation. So ordinary differential equation maybe says that a differential equation involving derivative with respect to a single independent variable. So we says that this is the ordinary differential equation. And now come to next point, which is a partial differential equation. So partial differential equation, what it means? It means say that a differential equation involving partial derivative with respect to more than one independent variable. So first of all, I am say about some independent or dependent variable. Let me show you in a class. So equation number 5 and equation number 6 is a example of PDE. So in PDE, involving a partial differential equation which have one or more independent variables, so we says that it is the PDE type, and ODE type it means which have respect a single independent variable. So we says that it is the ordinary differential equation. So these are the basic example for us. So dy equal to x plus sin x is equal to dx. These are the example for ODE. This is the example for ODE, also ODE, also ODE, and here is the also ODE, and these two are PDE type. Okay, this is a partial differential equation. So the basic need and use of this differential equation. So come to the next point. Okay, so here is the basic definition about order of differential equation. So what you says that order of differential equation, it means order of it means a highest order derivative involved in differential equation, which is called as the order of differential. And then degree of differential equation, it means higher derivative which occurs in it after the differential equation has been made free from radical and fraction as far as the derivative concerned. Note that above definition of degree above does not require variable x to u and free from a radical and fraction. These are the example of degree of differential equation. So here is some equation related to degree of differential equation. First equation, second, and sixth. These are the first degree type differential equation. Now the equation 3 is a first free from, and you have some root like given, then you first try to make it as a simple form. So we may be obtained like this: y dy by dx is equal to under root x dy upon dx ka whole square plus k, which is have a highest derivative, degree of highest derivative which may be occur in it after differential equation. So here we see that the highest derivative is 2. So the degree of this whole are 2. So this is the form of second degree. Again we must square both side 4 to make it for the free radicals. So definition degree of 4 and 5 are 2. So in equation 4 and 5 are the degree. Here is the uh, fourth and 5. These two are a part of OD and PD and their degrees is 2. Now come to the next point, and then we study about some problem related to the this differential equation which have some linear type of problem or non-linear type problem. So basically today I am going to teach about some problem related to this. Okay, so now the linear differential equation. Now come to the topic which have linear differential equation, non-linear differential equation. So here is the basic definition for us. Okay, so linear and non-linear differential equation says that a differential equation call its linear if first every dependent variable and every derivative involves occur in first degree only. Okay, in first case what you see that here you see that every dependent variable, every dependent variable dependent variable, and every derivative involved occur in first degree. Its derivative involved in first degree only, and second, no product of dependent variable and or a derivative occur. No products of dependent variable and or derivative occur. So everything is fine. A differential equation which is not linear is called non-linear differential equation, and differential equation which is linear if these 2 points are taken. First one is every dependent variable. It means their derivative occurs in involved in first degree only. And second one, no product of dependent variable and or derivative occurs. So these are the basic idea for comes to helping to find a linear differential equation. And non-linear, what it means, a differential equation which is not linear, which is called as non-linear differential equation. And here is the equation. First and six are linear differential equation because they have two properties. Every dependent variable, their first degrees are also given, and no product of dependent variable or derivative occurs. So example number 2, 3, 4 and 5 all are non-linear. So these are the basic example of linear and non-linear differential equation. Now come to the some solving problem. Okay, here is a problem given. So what is problem? The problem given as, so everything is clear visible. Let me make it up some bold type is okay. Okay, yeah. Now the equation for find the order and degree of the following differential equation and also clarify them as linear and non-linear. So question is what? Find the order and degree of the following differential equation and also clarify them as the linear or non-linear. So check at linear, for linear these properties hold, and the equation is which not linear, then which is called as a differential equation is not linear, which is called as non-linear equation. Wait a second, let me adjust. So the equation is given. You have question like this: equal to under root x in bracket dy upon dx, and close it, and then k dy by dx. Okay. So order and degree for which following differential equation, also clarify them as linear and non-linear also. Okay. So first what you do, multiply dy by dx both side. Okay. So multiply, everything is clearly visible or not, because I am not showing. Wait for a second, let me check on YouTube everything is clear or not. So everything is fine and no one can watch me. अभी देखो सालो. So sorry for that. चलो देखते हैं इस क्वेश्चन को सॉल्व करते हैं जिसमें बोथ साइड में हमें क्या करना है. सबसे पहले मल्टीप्लाई dy by dx. ओके, सो मल्टीप्लाई बोथ साइड्स of the given equation by dy by dx. This is a equation given. So we get, so now change it as like this. So y dy upon dx is equal to under root x dy upon dx whole is plus k. Okay, make it as equation first. When we multiply both side dy by dx, then it comes like this. So multiplying both side of the given equation by dy by dx, when we multiply here, let me show you. When we multiply here dy by dx, then it comes like this. This type, here is the equation written as dy upon dx, and when you multiply dy upon dx, it is cancel out, so only k is here remain. Okay, and then y equal to dy upon dx is equal to under root x dx का whole square plus k. Okay, so these are the solve. Then what is degree and order? Okay, so the highest derivative is given here, which of the first order and second degree, because the order of the highest differential equation, which is dy by dx, is 1 and here is 2. So order is so the conclusion is that which is of the first order and second degree. First order and second degree because the order of the highest derivative, the order of the highest derivative uh, not a clear word, it may be changed like this: highest differential equation, highest differential equation coefficients dy by dx is 1 and the highest degree of dy by dx is 2. Okay, degree of dy by dx is 2. Okay, so here first is a non-linear. Why? This is non-linear differential equation. This is non-linear differential equation because degree of degree of dy by dx is 2 and product of y dy by dx of dependent variable y and its derivative dy by dx occurs. Okay, so in B, part B, now here is the next question for us. Here is the next question for you. The question written as here, y is equal to x and then dy by dx. Okay, close a in bracket 1 plus dy upon dx whole square and then power 1 by 2. Okay, so the second question for you. First of all, what you do for this, you do rewrite this equation. Okay, and write like this dy upon dx, which is equal to a and in plus dy by dx power 2 and whole power 1 by 2. Okay, so first free for radicals. So to get rid of radical, so what you do, you do a square on both side. Okay, square on both side. So what you have obtained, you obtained like this y minus this x square. So here is the, when we use square, y minus x dy upon dx, which is equal to a 1 plus dy upon dx whole square and then power 1 by 2. You may be right. When we are squaring on both sides, it comes like this. So when you square, okay, make it a square on both sides. It comes like this. Here is the formula for a minus b ka whole square. And what its formula? Y square plus x square dy upon dx power 2 minus 2ab, it means 2y, 2xy. Wait a minute. Let me correct it. 2xy dy upon dx, okay, is equal to here is also right, then it comes like this. These are the cancel power only dy upon dx power 2 is remain. Okay, and here is written as like this a square in bracket 1 plus dy upon dx power 2 and then close it. Okay, so these when we are squaring on both side, the therefore imply these are a solution for you, and then it may be clear as the for order and degree for you. So here we see that the highest derivative, the highest differential equation of coefficient dy upon dx the degree is what? So write it like this. You have first order and second degree type outcome. Okay. So let me write for different color. Wait a minute. Can I use a dark color for you because it is a very clear visual to you. Okay. Here is which wait a minute. Hmm. Which of the first order and second degree because the order of the highest difference highest differential coefficient dy upon dx is 1, and the highest degree of dy upon dx. Okay, since so I think it is clear for you. The highest differential coefficient for your dy by dx is 1. So you get the first and second degree type. Okay. So these are the equation and their result is first order and degree type. Okay. So since you may be right as degree, since dy upon dx is the given equation is nonlinear. I think you got this point, and it's a good for you. It may basically use in semester exam or any use for. Okay, the today lecture for you. Now the time is I think 3:34, and in next class some solution about the equation. So the solution is like 2 or 3 used in for families of curve set of relation and complete primitive form solution type definitions, and then use a partial integration or partial solution, particular solution, single solution. So formation of differential equation also important for you, and their working is most important for us. So we discuss about some this type of problem, and now it is very helpful for you, and this format is good for or bad. Please say me in a comment box. Anyone watch these videos, please say me a suggestion for you to implement this lecture. Okay. I think in both language I am to teach you in Hindi and English, both language, but English is most superior for me. So I am say you, uh, it may be good for you also. So let me continue in English lecture. Okay. So anyone have related to this topic, please say me in comment box. So thanks for watching these videos. In next, we study about some solution type problem, okay, and which are very helpful for you. And basically, all class are important for you. So stay tuned with us. So meet you in next in these videos. Okay, so I'm quite this lecture today, and meet you in same time at in next. Okay, so thanks for watching these videos. I think time is best for you, or it may be changed to you. So I think all content